Good evening, everyone, to the second session. We had a very fruitful session number one, and hopefully you enjoyed all the presentations and the visionaries who brought their vision from the companies and the individuals. In the second session of this evening, we are blessed to have one of the pioneers in compiler construction. Those who have been in the computer science have dealt with Lex, Yak, and yet another compiler. You would be happy to know that our next speaker, Monica Lam, has a Dragon book, which is the most popular book on compiler construction and compiler usage. And to that extent, I can tell you, I know her professor, at least I know the CMU where she comes from. She did her PhD. Professor Satya is my great friend in edge computing, and she was selected based on just knowing that, hey, she knows somebody in CMU. But this is just a joke. But essentially, she is one of the persons who was recommended by Dr. Howard from Natia, and we tried to tell her that, hey, we need something very important which is in the edge computing, and she wouldn't give up. She says, no, it needs to be something on the work she is doing currently, which is very important, and that is to make sure that you don't have Siri, you don't have Alex, they don't drive the whole country or the nation or the globe, but you need an open source version of that. And that is her passion today. She wants to make sure that it's open with her compiler knowledge and all that is required to do the symbol table scanning and parsing and what you name it. You need somebody of that caliber to really challenge the established players. So we are happy to see from Stanford, Professor Monica, and I would like her to come and give her part of the keynote, which is exciting, and we want to make sure we don't say Alexa, now we have to say something else, that she will tell us what it is.
Thank you. All right, can you hear me?
Not quite.
Maybe I have to turn it on.
Yeah.
Is this better?
Yeah.
All right. So we're talking about connected world here. So I'm going to stay on topic because I'm talking about all the stuff that we have. Everything is online. All our information is online on some digital services and all the IoTs and so forth. And while everything is getting connected, I'm a little bit afraid that we are also seeing the threat of a closed internet coming up. And that's what I want to talk about. And why do I say that? I want to start by looking at what happened in the last 20 years. And I really like what Mark Andreessen coined. You know that guy, right? I mean, he's the one who wrote the first browser that was widely used. And of course, the VC here. And he said, software eats the world. It's just 4 little words. It's amazing. And we all know software eats the world. And as a matter of fact, it was not just software in general. There are 4 companies that eat the world. Can you name all the 4 of them? Google? Amazon? Apple? Yes! Oh my God! There's nothing new here. But what is interesting is that if you look at these largest companies, there are some very scary trends. First, it is a very centralized system. Okay, I mean, Amazon is selling everything to everybody. Okay, you don't have a lot of retail shops anymore. The largest retail companies are not doing well. We're also seeing a lot of near monopolies, if they are not already monopolies. We also have closed systems. So for example, if you look at iPhone, all the apps on the iPhone, anybody can write them, but they have to sell them through the iPhone, the Apple Store. Okay, imagine Microsoft saying that. Okay, we have now a PC, anybody can run software on it, but I'm going to take a 30% cut on every bit of money made on the PC software. Okay, That is just unbelievable back in those days, but that's where we are today. And finally, I think that the more worrisome of them all is the Facebook business model. Okay, so what do? They help consumers share information with each other socially. And for that, they ask for no money, but they ask for all your data. Okay, it is amazing. They just say, I'm going to take over all the data, and now we have billions of people's data being owned by a single company. All right. So this is where we are today. So what's going to happen next? We all know this is the Bay Area, right? I mean, we all know that companies come and go. So if these are the eaters today, who's going to eat these eaters? And the thought here is like, can you imagine somebody who is as big as all these 4 companies put together? And I think that that's a possibility, and that will be in the form of a virtual assistant. Everybody here knows what a virtual assistant is, right? I mean, think about the ads that were put out on Super Bowl, on virtual assistants. Everybody watching football knows about virtual assistant. Google is putting ads about virtual assistant on TV constantly. Why? Because this is really a major prize. Whoever wins the virtual assistant owns the world, in a sense, owns the internet. What does the virtual assistant promise? It says that, look, in the past, we have to adapt to what the computers do for us. Now it's the time for the computers to adapt to us. It is using our natural language interface with, to talk to us. I don't have to learn how to interface with program A, B, C, D, E, F, G. Okay, I have a virtual assistant that understands all the different services and data that I subscribe to. It knows everything about me, and then I can just say what I want, and it does what it takes, and it connects to all the different services. They read my email. They know that I'm going to be going on a trip. They can buy me this plane ticket before I start searching on the browser, right? Of course, if you are using Amazon, everything you buy will be from Amazon. Everything you search on Google Assistant will be from Google. It's not going to be from Bing. So whoever who owns the virtual assistant is kind of like it's disintermediating between us. They're intermediating between us and all the different services. They can push any service that they want, and they know everything about you. It is really hard to beat because that would be a very, personalized interface, and this is where we are heading to. So with the virtual assistant, you don't have to go to different websites, open different apps. You don't have to go to a search engine, and you just tell the virtual assistant what you want. And this is why I think the virtual assistants are going to eat the internet. Now, what do we do? Is there any alternative? Of course, these are the 4 really, really large companies who can compete with them. And so what we are worried about from a consumer's point of view is that there may be one company that knows it all, okay? We're losing privacy and actually losing it to one company. We don't have choice. From an industry point of view, we're talking about monopoly. We're talking that owns people's data. And with that, we're going to lose competition, and we have no open competition, we have no innovation, and then the consumers will suffer. Okay, so this is where we are heading. I mean, if you just look at what happened in the last 20 years, it is really not hard to imagine that this is going to happen. It's going to be like a merge of the 4 industries into one. So what can we do? Who can compete? And I think that if there is anything that can compete, it has to be open systems. If you look at, there are 2 interesting examples. Of course, we know about Unix and Linux. And if we did not have Unix and Linux, what kind of phones would you be using today? It will be your Windows phones, right? But now at least we have 2 alternatives. It was because a long time ago, Bell Labs, Berkeley, a lot of people worked on an open source operating system. Another good example is Wikipedia. It is an open knowledge base. It is information for everybody. It is not owned by Google. It's not owned by any one company. And I doubt if any one company can make that happen. It is completely a crowdsourced effort. And what I think we need to do is to absolutely build and crowdsource a virtual assistant, a open source virtual assistant. And we started this project at Stanford, and we call this Almond, and it's an open source virtual assistant. So one thing we know is that you cannot just take something that exists and make it open source and expect people to come. You really have to look ahead. What is going to be the future virtual system? We are a research group, and we want to start building what is going to happen in the future. And our vision here is that in the future, the virtual assistant is going to be programmable. It is not like, I say, turn on the light, it turns on the light. Close the door, it closes the door. What good is my secretary if I have to tell him everything that I am doing, every step that he has to take, one bit at a time, It's like, go type in this letter, go do this. No, you don't do that. You tell them what it is that you want, and then they can accomplish the task at the right time, periodically, and they can adjust to the situations they have. And we believe that the virtual assistant in the future is going to be programmable. Well, what does that mean? Let me just give you some common examples. So here's what we imagine to be a day in the life of Almond. You say, so for example, I have to worry about groceries. So I'm going to tell my virtual assistant, every week order milk, eggs, and bread, but don't do that if I happen to be traveling. Of course, my virtual assistant knows my schedule, and it will just do it automatically. It's kind of the kind of smart assistant that you expect. There are a lot of social media out there. I don't really have the time to look at them all, so I might want to filter them based on how popular it is. I want to be able to order paper when it runs out. I want to be notified about the Stanford women basketball games. Here's another example, is like I want to call an Uber at the end of the day, but I know that I cannot order in advance. So I tell my virtual assistant to say, every day, while I'm having my meeting, 20 minutes before the meeting finishes, go and call an Uber for me. Okay. So these are examples of these rules and things that you would like to tell a virtual assistant you want that assistant to do. So in a sense, some of these things are the kind of things that you see Google now doing, right? They automatically suggest things to you. But I'm not a big believer in this, okay? I don't really expect my secretary to just guess what I want to do. I need to be able to tell him what I want done. So it is really important because, everybody is different, everybody has different needs. Let's take, for example, a person who, say, has asthma. It's a chronic disease, and he needs to manage it. And now with all the IoTs and information about the environment and so forth, I could potentially manage this kind of diseases like asthma very well with the help of technology. So Bob here, who has asthma, may want to say that, look, I'm using these inhalers. I want to know where I am when I use these inhalers so that so I can find out when do I usually need the help with the inhaler. And you may need to be taken to a hospital. I want to make sure that my dad knows about this. So this is a kind of thing that Bob may want to tell his assistant. In the meantime, you have IoTs. You can also improve things like healthcare. You can say, look, I am using my fecal meter to measure how well I am breathing. And if it is below a threshold, I want to be able to tell my doctor about it. And then you say, look, I'm sensitive to one kind of pollen. I want to know that if I'm running and if it turns out that ragweed's pollen count is high, then I want to be warned. So these are all the things that you can imagine this person saying. And everybody has a different need. So I want to know who's going to write this piece of software for Bob. Bob is. So the point here is like, if you look at the software that we have been using, only the software that can be monetized is built. Okay? When they put Facebook together, what kind of features do they put in there? It's features that can make Facebook more viral. Okay? can serve a large number of people who wouldn't mind not owning their data. Okay, they're going for the masses. Okay, here is a large group of people I can serve. I can make a lot of money from. I look at an example like this. Who is going to spend all the time doing a really good piece of software that helps an asthma patient, which may be different depending on where this person is? Okay. But if you look at the technology that we all have built all these years, right, this is the kind of thing that we know we can do. It's just a matter of who's going to write this code. So what I want to do is to create an infrastructure such that the individuals can code it for themselves. The end user can do the programming. But when I say end user programming, I mean that they have to do it in natural language. Okay? I mean, I'm not going to ask everybody to learn how to write in JavaScript and so forth. What I really need is end user programming. So what we see here is that if I have a smart agent like Virtual Assistant who can already, keep all my accounts and all my credentials and who can do so many things already, I want to be able to program that guy. Everything that I showed you just now are things that can be done by a virtual assistant. But everybody has different needs. And in other words, I want to be able to program this. And this is the way we're going to be able to serve our long-tail interests. People who have asthma have a different needs. People who like to play soccer, they have different needs. And we want to have autonomy. I don't want to say, this is a piece of software that can make a lot of money. Now we can hire enough engineers to build that piece of software. I want programming, which is, obviously very, very useful to be available to the individuals. And by making all this available to the individuals, they can do things with their virtual assistant in a way that is private. Not everybody has to be treated like the same and being served by the same piece of code. So that's the beauty and the importance of end-user programming. So when we say programming, it's like, what do you mean? I just show you some examples. They look like sentences. Why do you call them programming? Let's take a look at this one command. Suppose I want to get into investing, and I say, okay, when the price of the Apple stock goes below some number, and I want to know I have enough money in my checking account, I want to be reminded. I may want to buy some stock, so this is, I want to be reminded with the price. So here's an example of a program, in a sense, because if I look at it, it is not just a simple command like turn on the light, turn off the lights. It is actually an event-driven program. Okay? I have to watch for situation. I am connecting different kind of services together, my Apple stock, my checking account, my SMS. No, my virtual assistant has access to all these. These are all my accounts, and the only person who has all of these accounts is the virtual assistant. So I need to connect the different functions together, and I need to pass parameters around, and then I may have to put filters on these parameters. This is programming. Okay? But this is programming at the level that end users understand. So the key technology behind this is kind of like compiling, but we have to take natural language and turn it into programs. Now the programming, the high-level programming language is all the way at the natural language level. So I need to take this natural language and create code. What kind of code would it be? Okay, it is not just something like existing programming languages like JavaScript or Java. I mean, I'm not going to start telling for I goes from 1 to n. I don't need to do that. And we actually invented a new language. We call it ThinkTalk, so that the things can talk to each other. So this is what the ThinkTalk programs look like. If you give me that piece of that sentence in English, it would generate this ThinkTalk code. It says monitor the stock price, the parameters, there's a filter. If this is true, then you go get the balance, another filter, and then the third thing is that I have an action, I send SMS. So I am monitoring some condition, getting some more data, and doing some action. It is a very simple construct, but it is very powerful for the reason that what I can say is anything that a virtual assistant can do. Even though it is a very simple construct, when, get, and do, It is very powerful because all the things I can hook up together are now huge. How big is it? Amazon today has 25,000 primitives. Okay? And when you have 25,000 primitives, you can combine 3 of these things together. There are many combinations. You can put in the filters, put in the parameters. You have yourself a very powerful programming language. And today, Amazon has its repository of 25,000 skills, and it is growing. And it's a proprietary repository. This repository is only available to Amazon. Okay, and if you put things in there, it's their proprietary system. If they don't want to buy things from you, they don't need to call you. Okay, it is their control. So Google is doing the same thing. They have their repository. We really don't need to have proprietary repositories one after the other. We really need an open repository that represents. It's just like the www address. Anybody can go anywhere, and this is why we're building an open crowdsourced repository we call Thingpedia. Like Wikipedia, okay? But it is about Internet of Things and services. We open it up for everybody. You put the information in there, Google can use it, Amazon can go use it, anybody who wants to build anything can use it. It's just like information on Wikipedia. Now, that's the program that you want to be able to write, but you want to generate that code using natural language. And the key thing here is the semantic parser. We refer to this as the ThingNet. So ThingNet is a neural network that tells you how to operate the world. I say something in English or in natural language, and the code gets spit out, and then it gets executed. And if you think about the advances in AI, this is just a matter of time. I mean, we can now recognize all the objects in images. This is actually easy because the kind of things that we can do digitally is still very, very small number. And I truly believe that it's just a matter of time. There will be a neural network that says you put out the English, all the things that can possibly be done digitally will be generated at the other end. The only question that I have is who owns this thing now? And I want this ThingNet to be open and available. So this is the architecture. There is the language construct, the ThingTalk. There is the Thingpedia, which is the libraries, really. It's just the largest open world library. And then you have the translation process. And we've been at it for about 2 years. And it is only this February that we actually have something that trains. And in order to make this happen, we have to tune the programming language, we have to change the repository representation. And I would say that today our repository representation is much more interesting than what is in Amazon. The reason is that we are not just doing simple primitives, you call it does something. We are actually putting programs together. When I do an operation, I actually return a result which can be used for another primitive. We believe that by looking ahead, we are building a representation that is much more useful than what they are trying to do today with the current product. And this is how we attract people to this one. Because we have capabilities that are beyond what they can do today. So anyways, so we got the whole system. It is a small system, but it actually can understand natural language to the extent that I'm going to explain. So what have we got so far? We've built an encyclopedia of things, a Thingpedia, with the help of our students. We crowdsourced it from the students, and right now it has about 44 devices, less than 200 functions. And just give you an example of how, just give you a brief look about how things are built. So we talk about that there are the when commands, get commands, and do commands. For each type of commands, we would say how do you call it up in natural language, and what is the code? Okay. So when Stanford tweets, that's the code that you're supposed to generate. So we keep track of what are the natural language snippets and what are the code that is being generated. So here is a cheat sheet of all the different functions that are callable. As you can see here, there are a whole bunch of them. When's on the basic monitor gets are things that you can get, and then the do's are actions, and you can plug them in arbitrary ways. So let's talk about the language. The code is very simple. When, bunch of filters, get filters, and do. So for example, when my alarm goes off, open my blinds. So that's the monitor, and then that's the action. Or the last one here is like when I receive an email from my advisor, send a message on SMS. Okay, that's the one that I like because I want my students to respond to my email. But you can see that this is all tailored to what an individual can use. So these are the examples of compound statements. So what we do is that we take the entries from Thinkpedia and you can hook them up and you can write programs. But of course, we're not just taking the existing snippets and putting them together because we are, we use languages in a natural way. So if I want to say something like, when I tweet, share the text on LinkedIn, there are many, many different ways in which I can say it. Share my tweets on my LinkedIn. Whenever I tweet, post the same message. Post all my tweets. There are many different ways you can say, and this is where the machine learning comes in. So I don't have the time to get into how we build our semantic parser. Just give you a very brief description. It's a seek-to-seek neural network attention, and in order to make sure that we have compositionality, which means that we can compose a new programs that we have never seen before. Machine learning is very good at remembering frequently mentioned sentences. Okay? But here we are programming, we need to construct a new kind of program. And for that, we represent the program as bottom-up grammar productions. And so this makes the neural network a lot more, make it better at compositions. And with the, we take the data, we take the sentences, we ask Mechanical Turks to rephrase it in English, and we use that for training, and we see that we are doing pretty well with the data set that we have. So we are releasing this data set when our paper gets published, and the whole idea here is that we want to make all this available and get a lot of other people to do the machine learning research on top of our data set. So that's the basic idea behind the virtual assistant. One of the most interesting uses of virtual assistant, I believe, is helping people with sharing. Okay? Just look at what we're doing with Facebook. Just because they let us share, we give up our data. So the first thing I want to show you is how a virtual assistant can help us share better than anything else that we can come up with. So the idea is as follows. So I already have all my accounts. I trust it to my virtual assistant. It is an open source software. That means that I can take this code and compile it and run it on my Android phone. Okay, and all the credentials and all the data of my accounts are kept only on my own devices. So I can do that through everything that I own. Now, you may have your virtual assistant who manages your resources. If we want to share, a simple way is for you to come to my virtual assistant and ask for the information. I will tell my virtual assistant what I allow you to read, and my virtual assistant will actually execute the request on your behalf and then give you the results. Okay? In other words, I'll give you an example. Suppose I'm on Facebook and here's a real example. Okay, Stanford has a Facebook account and they ask the students to join the incoming class to join the Facebook 2022 account. Okay, imagine that there is a student who says, I really don't want to join Facebook. We really shouldn't push the student into Facebook. So what we can do is to have Stanford have a virtual assistant. Then the student goes to the virtual assistant and say, can you please share with me everything that you post on Facebook? Virtual assistant executes that command. Okay, the Facebook virtual assistant executes a command. Whenever things are posted, it takes the information and share it with the student. So this is an example how I can share something that is inside in a proprietary service with people who don't even have an account on that service. Without me sharing the password. So that's the basic idea behind how you can make virtual assistant share everything. Because my virtual assistant can share information on, can execute your command on your behalf and share the information. And of course, sharing means access control. And it is amazing. It's like the support for access control at this point is so weak. What do? Facebook gets to decide. If they said, look, you can have friends of friends. Anything you put on your wall will be shared to friends of friends. And that's it. You can choose to do it or not. They have come up with a few rules and you say yes or no. That's all you can do. What we see here is that if I have programmability, I can do a lot better. So here is an example, a couple of examples. I can say, let my daughter, my daughter can use my Netflix account between 6 and 8 p.m. So now I'm implementing parental control. Or I can say, I have a security camera. When I'm out of town, only when I'm out of town, my father can help me monitor my house security by looking at my security camera. But only if I'm not home, because I don't want you to be watching me when I'm at home. So these are English sentences that help you share sensitive information, IoTs, accounts, parental control, what have you. And now, as you can see here, these are programs. I can tell you who it is, what action you can take, what is the condition, I have a lot of flexibility over how I share anything that I own with the help of the virtual assistant. This is why the virtual assistants are really powerful and useful if you can control it, if you have this, if it is open source. So what we did is that we took all these constraints and we compiled them down to SFTs, satisfiability, modular theories, formulas, and we enforced the access control, and we showed that it is fast enough. Okay. So this is the backup. And what I've said so far is all about virtual assistant as we know it today. Most people think of virtual assistant as command line virtual assistants, but we don't have to stop there. So we have also got another couple of projects where we play with multimodal virtual assistant. So let me show you an example. So our project is called Reusable. And what we discovered is that a lot of people, when they issue commands to the virtual assistant, they say the same commands over and over again. But the virtual assistant of English is really pretty bad. And you see people get frustrated because they don't understand you, and then you try to say it over and over again. So what we realize is like we can combine the advantages of natural language with GUI. So a user can say, here are the kinds of things that I like to say. I want to monitor the camera in the baby room, or I want to monitor mails from my dad. I want to be able to order coffee, and I usually order it this way. I say it in English sentences, and then the GUIs are automatically generated. Okay. All these GUIs are automatically generated by our system because all this information is in the Wikipedia entries. We're really getting into a point where everything is very customized for the individuals, and at the same time, the open source can get the privacy. If you look at these GUIs and you say, oh, it's kind of okay, not particularly beautiful. So we've been working on actually making them even better than what typical human designers can do. And we turn to machine learning techniques. And what we realize is there are a lot of masterpieces out there that are beautiful in art, and we take a GUI, up on the top is an example of a GUI. If we are automatically generating it, they are not necessarily the best looking. So what we have developed is a machine learning technique that lets you pick a piece of art, and we automatically recolor it, restyle it, and turn it into beautiful GUIs that fits your interest. So what we are now talking about is a world where the individuals can customize the functionality as well as the aesthetics, because we don't want to just give the people a poorer experience. We want to give people even a better experience than what they have today. So in summary here, I think it is really important that we start this effort. The people, the researchers before us started with Unix, and Linux, and so forth. And it is time that we do the same thing. The virtual assistant is going to be kind of like the new operating system. And we should pull together, get our effort together. The task is actually, the interface is actually very rich in research content, because now it is all using machine learning, using AI, and this is an area where I think that academia and industry can work together. So in summary here, virtual assistants are going to eat the world. We believe that end-user programming is a very new way of getting us out of this current style of very much centralized monopolies. And the AI has been used in many, many different disciplines. It is about time that we apply it to system, to make the system with privacy something that people can actually use. The usability comes from the AI techniques that we apply to systems. We are getting ready to release the software for the first time, probably in June. And we have a prototype out. There's an Android app, and then there's a website. Well, thank you for your attention.
Hi, thank you. We have queues. Come on. Start. First question.
Yeah, thanks a lot, Monica. That was great. I think it's really nice to think that Bob can write all his own programs, but I'm not sure how realistic that is. I'm not against end-user programming, and it would be, I certainly love the idea that Bob can write programs for himself. But does it make sense to think in terms of having a baseline that can be customized by each individual, or multiple baselines?
Absolutely. I can imagine that given the virtual assistants, then there might be a group of people who say, I'm just going to help people who have asthma. And these are the kind of things that you can do. But it is now easier to write, because you've got a virtual assistant that handles all the credentials and so forth, and it has the event-driven loop, and it is watching everything. And so you can imagine that it is easier to write reusable software, even if the individuals are not thinking about what they can do for themselves.
Although it does bring up issues that have had to combine these modules in the core.
Yeah, I mean, right now, what we find is like, even something simple where you have a when and get and do put together, it's already very powerful. We started seeing the limitations of it, but it is just a matter of time. The next thing that we need to deal with is data, because so far we are hooking up the input to the output. We haven't really done much with the data, and you need to be able to process that, and that is something that we kind of need to work on. So if you don't mind programming, ThinkTalk is actually a very deterministic programming language that is at a pretty high level. So there might be people who want to deal with that, as opposed to just leaving it to the individuals who are going to deal with the inaccuracy of the semantic question.
Thank you.
Hi, Rick Hoff again. I was curious, one of the things this immediately from in New York was IFTT, right? If this and that, if people don't know about it. And I'm curious, what made you kind of go out and create a repository of recipes and connected devices, etc., versus perhaps leveraging an existing set of, GUI-based, user experience that's being set up by IFTT and a couple of other competitors that they have? Is it because it is a closed system, or what's your thought on it?
IFTTT is a closed system. As a matter of fact, if you want to use IFTTT, suppose I want to say, monitor my checking account, and when it is below a limit, let me know so I move money from the savings account. You have to give your checking account credentials to IFTTT. it's just not it's a non-starter for me. Right? As a matter of fact, a lot of people were complaining. They said that if you contribute the API, that API is owned by IFTTT. You don't even get to keep it. Right? And then the truth, but the good news is that if you look at IFTTT, they showed how many, I think they were like hundreds of thousands of recipes that are available. So there is a little, it shows that there is some kind of demand for it. But because the privacy model is so terrible that if we honor privacy, I think that will grow even larger. Okay. And the second thing here is that we played with graphical user interfaces. It is bad enough with 177 functions. Okay. Imagine that you have to go down the menu to figure out which function that you want to call up, and then you select the parameter and so forth. It is very, very different if you can do it in natural language.
Thank you.
Great presentation, really inspiring. Thank you. Two questions. Number one, can you think of speech input, speech recognition instead of typing? Because it would make it much more user-friendly. The second point is, I have seen human assistants getting fired for making mistakes.
Yes.
How can we fire the virtual assistant if they book for me a first-class ticket to New Zealand on a day I can't leave?
Well, good questions. The first one was speech. Okay, I believe that is an orthogonal problem, except for one point. So there are plenty of people who turn speech into text. So I would love to have somebody contribute that piece of software. But today we are using the Android input as speech to text, or you can use Microsoft APIs and they give you a limit. So that's orthogonal, except for one thing we noticed, and that is the quoting of the text. Suppose I want to say, write a mail that says hello to somebody. If I type it, it's easy for me to quote it. If I say it, it is really kind of awkward. It's like, say this, quote, blah, 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 and then quote. So actually, this is one of the problems we have identified that we need to solve. We're playing actually with machine learning models so that we can automatically detect like quotes activity. But otherwise, it's a kind of orthogonal. The second question is firing. Well, I fired Siri a long time ago. Why? Because Siri would make phone calls without me even asking it to call anything, on anybody, right? And so one of the things that we did is that we make sure that every thing that we execute is read back to the individual. Okay, I say this, and then I say, okay, you mean blah, 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 blah. And this is critical when it comes to remote execution, because we all know that you don't want to execute foreign code. If I say to your virtual assistant, can I look at your checking account? Okay. So the English is converted into ThinkTalk. But what we ship over to you is the ThinkTalk program so that your virtual assistant will read the ThinkTalk back in English to you. So that it's just not me saying it is whatever it is. So we're very careful. So right now we are kind of counting on the confirmations to make sure that this is what you need.
Hi. Question, philosophically, how do you see this as a viable thing to do? Let me give you some examples. How do you think this is going to survive? Because many open source companies kind of acquire it, and of course they still give you the free version, but they take away many options and you got to pay for those. Give you another example. Wi-Fi was never supposed to be an offload medium for the telcos, but they did anyway because there was so much Wi-Fi, wireless access. The telcos started offloading once they found out that they could use a Wi-Fi network in congested areas. So they kind of encroached on it and they occupied it. What is to stop Amazon from occupying ThinkTalk or Thinkpedia?
So I think that what we are talking about is not just a pure academic open source project. How did Linux get used. It's used by Apple in the iOS, in macOS, and also Android. And here's an example where it is started as just open source project. Eventually it gets, if it is not Apple and Google, they will not get the kind of distribution it takes for that to become a platform. Okay. So we are hoping that there will be people other than the number 1 and number 2 and number 3 who may find this to be a way for them to get into the market. So that's one thought. There's a second reason why I think we have a chance, and that is that unlike Facebook, which is it's a C2C product, okay, natural language interface is a B2C product. There are many businesses who do not want to send all their sentences to Amazon to be translated, okay, because you're losing all your user relationships. And what we are saying here is like, this is the basic technology. We put it out there, and we are just hoping that a lot of people will find the need to adopt this, because we're now replacing GUIs with natural language. Okay? And if you don't put some technology out there, it is a little bit harder. It is hard for a lot of companies to have a shot at building a natural language interface. Thanks.
Hi, great talk. My question is about the natural language processing. I used to work for an organization that was using NLP to mine treatment rationales from doctor's notes. And this was used in like tumor board meetings and things like that. And we used Parspace and some other parsers to generate our semantic tree. And we actually consulted with a professor of cognitive science at Stanford, if you might know him, Jeff Schrager.
Okay.
Yeah, but the process was very error-prone, and we could never get it to work right. And we ended up actually having human volunteers sit and take those notes and convert them into like a controlled natural language, and then use the parser to actually parse it. So I find this very interesting. I was wondering if this virtual assistant's not the Thinkpedia, but the ThinkTalk parser would be able to parse any kind of natural language, and if it can learn some medical jargon. For example, if a doctor said a patient with colon cancer should get tested for a KRAS mutation because, you know, some rationale, and would it be able to parse it? Is this technology generic enough that it could be applied to other problem domains?
So, no. I think that it is not trying to understand any arbitrary sentences. I'm trying to execute a program for you. Okay. If you look at how Alexa works today, first of all, it doesn't work very well. Okay. But the truth is that we all learn how to talk to Alexa to maximize its ability to understand us. Say, ask Bing to search for blah, blah, blah. Okay. We are not talking to a 2-year-old. Okay, we're not going to try to fool it, because it is not to my advantage for it not to understand me. So in many ways, we are getting people to adapt to what it takes, but it is still so much faster than doing GUIs. Click the button down, select this and that, and then so forth. And I think that that's what we're counting on. I think that there are lots of practical things that can be done, such as when we notice that people are having problems with long sentences. We say, okay, once you get one sentence in there, we create a GUI for you. If you want to just change parameters, you just click a couple of buttons. So there are a lot of practical things that we make it kind of come halfway to meet the where we are in technology.
So my question is related to hers. So if something doesn't exist in ThinkTalk, a scenario which you have not thought about, can a user program it? So for example, I don't know, you want, so most of the examples you gave were for urban, right? So if in urban setup?
Urban, yes.
Yeah. So, but then if in a rural setup or a farm setup, somebody puts some smart sensors on a farm or something like that, but that doesn't exist in a user.
So the key here is that Thinkpedia is how the virtual assistant knows its stuff. So if you want to, you can put in any of these functions yourself into the system. And it is the same parser, but now the data is different. And it will be able to handle those new sentences. As a matter of fact, when we talked about this work with some pretty large consulting firm, they were saying to me, it's like, what I'm showing here is something that is very useful for companies because they have a lot of employees, they repeat work, they have to do the same thing over and over again. It would be very useful for them to kind of define their own virtual assistant commands and have that being executed using natural language interfaces. So this is really a programmable system, and for different purposes, you can just stuff the Wikipedia with different entries. A kid can make his little robot respond to natural language if they want to, okay, by putting the information into Wikipedia. It is designed to be extensible.
So you can add a sensor which didn't exist and monitor the parameters for that without even going to the...
Yes, you just have to enter put the entry into Wikipedia.
Have you thought of it being something which can assist the disabled and the disabled?
For the disabled? I think that they are challenging. So the people who are designing it has to deal with what it takes to make it work. To some extent, I mean, if you look at accessibility interfaces, they are helping people who cannot type or who cannot read, and this is where the voice comes in. And so, in a sense, that could be useful because we are really enabling more people to be able to control things using speech. So, in that sense, I can see some usage.
Thank you.
Thank you.
Last person. Thank you very much. Very informative. Two questions I have. With a security and privacy background, should I be now more worried about the virtual assistant and on the device there being too much of information? So if I lose it, would somebody now have more information because of the Almond Virtual Assistant on my phone?
Well, we can use the standard techniques, right? You can take your code, you can take the information on the phone, encrypt it, and save it in the cloud. Okay, so there's nothing that we are doing that makes it less secure in that sense. But in the past, there is very little consumer, there are very few functions that make it easy for the consumers that actually don't take the data.
That's true.
And this is an example of what we are doing here, is to give people a choice. And by the way, I know that the audience that I speak to, a lot of them care about security. But the truth is that the world is full of people who don't. And one thing I have learned all these years is that you need to build a system that serves all kinds of people. What I envision in the future is that this virtual assistant technology is kind of like email, right? There will be the Googles and the Microsoft or Verizon email that says, I'm going to be your virtual assistant. Trust me with it, it is free and I will give you whatever. But what is important is that it is at least something that is competitive, okay? It is not single source like Facebook. And an individual like Hillary Clinton or people who care about running their own server, they can still do that and interoperate. The companies and the universities, they can still interoperate with those free consumer services. And I believe that that is the architecture that we need going forward. So you have the choice of how much security and privacy.
The second part of the question, I could have 100 friends or family members which my virtual assistant is working with their virtual assistant.
Yeah.
And I unfriend them on so I programmed them to send them messages or my tweets. And can I now undo those programs? How difficult would it be
You want to undo those programs, then you just disable them.
So you just have to go through some list and that in the program you can see all the programs and then just
you
undo.
can see all the things that are being enabled. Actually, if I, in the example where I have the Rousseau, everyone has an enable disable button. You can just toggle them.
All right, thank you.
Okay?
Thank you very much, Monica. And I think if I have the choice, I can call Almond and ask when Monica finishes, Shobha, please come in to give her the award. Professor to professor. P2P communication.